Now direction, I've been sort of using it already, but this is the direction part of this lesson. So conventional bearing is a point stated number of degrees. Oh, that's the conventional bearing. I like using like the cardinal direction. That's probably more widely used in real life. Maybe the conventional bearing is something that you might use in math class or something. But the cardinal direction is basically what we're looking at. So the cardinal direction of a point is stated as number of degrees east or west of the north-south line. So I've kind of looked at that over the past example. And we refer to this conventional bearing simply as direction, which is what I wrote up here, cardinal direction. So to state the cardinal direction of a point, we see where the point is, if it's above the east-west line or below the east-west line. If it's above, we start with north. If it's below, then we're going to start with south. And then we see what the angle is, and then we state that angle, and then we see, is it to the right or the east of the north-south line, or is it to the west of the north-south line, and then that determines what angle we have. So, for example, in this diagram, point A is north 30 degrees east. Okay, so it's closer to the north. It's rotated 30 degrees in the direction of east. So north 30 degrees east. Point B is north 60 degrees west. Okay, what will C be? What would you do for C? Okay, we see it's south of the east-west line, 70 degrees towards the east. So it's south, 70 degrees east. And then for D, write this in here, please, what the cardinal direction for D is. Okay, so that would be south, 80 degrees west. Okay, so that's where we're going to, how we would use cardinal directions. So I looked at that earlier, and this just kind of confirms what we were doing there. We can also look at the bearings here. So A bearing is 0, 3, 0, so 30 degrees. C, the bearing is, well, we know this is 70, and because between the south and the east, that's 90-degree rotation in here, and it's 70 degrees from the south, that means that this has to be 20 right there. So the bearing is 20 degrees further than 90, so from north we go down to 90, and they add to 120. So this is a bearing of 110 degrees. And then for D, same sort of thing. We rotate around 90, 180, and then another 80. So that's 260 degrees, which makes sense because it's a very small angle here to get back up to 270, which is the west. And then if we go past 90, past 180, past 270 to get to B, well, we know this is 60, so that means that what's ever left over here has to be 30. So 90, 180, 270 plus 30, so that means that this is a bearing of 300. Okay, let's take a look at a real world scenario here. Shirley takes her dog to a no-leash zone, and upon entering the gate, Shirley unleashes Fido. Of course, that's what you do in an unleashed zone or a no-leash zone. So the important thing when you're reading things like this, you want to draw a diagram, because if you can draw the diagram well, then that means that you're kind of halfway to solving the problem. It makes things so much easier. If you just try to do it all linguistically, you may run into troubles. Okay, I'm a visual learner myself, so I like to draw a diagram. So when you draw the diagram, before you start drawing things, you might want to take a look at what the whole problem is. So Fido walks 150 meters heading south 25 degrees east. He then sees a cat and runs 75 meters heading south 5 degrees west before the cat runs up a tree. We want to know how far the tree is from the gate. So you sort of want to pick a spot where the gate would be. So let's say there. So if the gate's here, I want to say, okay, well, Fido is walking 150 meters heading south 25 degrees east. So from here, south 25 degrees east. Okay, so I'm going to draw a little compass rose here to get the cardinal directions, so I can draw that, but I just want to kind of visualize it first. So he's going to be going, the fighter's going 150 meters in that direction. Then from there he sees the cat and goes south 5 degrees west, so he's going to be going in that direction. So if I start with the gate here, it looks like I'll have enough space on my diagram. If, however, I said, okay, well, the gate's going to be over here on this side of the paper, to do south 25 degrees east, I'm going to run off the page. Okay, so you don't want to be that close to the edge of the paper. Also, if I were to continue, if I could fit that in, I'd run the space down at the bottom of the page. So you want to sort of find out where it may be, where the diagram would be drawn. If, however, the problem was talking about going north, you don't want to start the problem up here, because if you go north, you're going to be running into the problem and into further work up above. So you want to be a little bit strategic in where you draw your the gate and the compass rose. So I always like to start off with a little compass rose here, just so I've got some sort of a place to start. Okay, it doesn't have to be that big. I think I drew that a little bit bigger than I wanted to, but anyways. So we know this is north, so just draw an arrow for north. And so we know Fido walks 150 meters heading south 25 degrees east. So south 25 degrees east, so this is east over here. So 25 degrees east, and you don't have to do it perfectly, just ballpark it. 45 degrees is halfway, so 25 degrees would be a little bit less than that. So I'm just going to go a little bit less than halfway, and I'll say that's 150 meters. So now these diagrams can get kind of crowded pretty quickly, so what I'm going to do is I'm going to draw an arrow to indicate where that 25 degrees is. Okay, so it's right in there. Then, so he's going 150 meters there, and so he walks along here, and there he spots a cat, and so I'm going to draw another little compass rose here, keep the north line parallel to the north line of the previous compass rose that I drew. Okay, this is north. And so from there it says he goes south 5 degrees west. So if we know all of this in here is 90 degrees, 5 degrees is going to be very, very small angle. So we'll draw a very shallow angle here going 75 meters, like that. So I know that this right in here, this tiny angle right in there, is 5 degrees. Okay, so that's kind of small. Anyways, we want to know how far the tree is from the gate. So here's the gate, here's the tree. We want to know this distance. So I'm going to draw a really light line here, because it's going to start going in between. It's going to go in the middle of this angle here, and which I don't want to obscure. So I'm just going to kind of line it up and then draw a light line there. So we want to know this distance, x, for example. So we've got this side, we've got this side, we want to know this side. We need to find some angles in this triangle that we just drew, or an angle in the triangle we drew, so that we could figure out what to use to find this side here. So this 25 degrees up here, this 25 degrees is of this initial direction that Fido was walking. It's not 25 degrees inside this triangle. Okay, this 25 degrees is from south to this line. This side of the triangle is not perfectly south, so that 25 degrees is not part of the triangle. So what we can do, we need to kind of ignore up here for now. But what we can do though, because remember when we were drawing this, that I said that this has to be parallel to this here. Well, if we've got this parallel line, or this north line and this north line parallel, then we got two parallel lines and we got a transversal cutting through both of those. So that's a situation where we can use the parallel lines theorem from grade 9. So I know this is 25 degrees, and if I can visualize the Z pattern here, that means that this out here is going to be 25 degrees. And then we got 5 degrees out here, so now we're getting someplace. Now we've got, if I know this whole thing, this whole quadrant here is 90 degrees, and I know this part right here is 25, then to get this part of it here, that means it's 90 minus 25. So that would be 65 degrees right here, and that's inside the triangle. Now at this bottom portion here, in quadrant 3, this is 5 degrees, and this whole quadrant again is 90, which means that this part here is going to be 85. Okay, so now we've got two angles inside the quadrants, inside the triangle, and to form this large obtuse angle we would add those two angles together. So this is going to be the contained angle between the two sides that we know. Okay, so 65 plus 85 would be 150 degrees. Okay, so now we're at a phase that we can actually solve for x. We've got one side, we've got a second side, and we've got the angle between those two sides. So that's where we have the two given sides and the contained angle. So would we use primary trigonometric ratios like sine, cosine, or tangent? Or would we use the sine law, where we have an angle and the side across from it? Or we would use the cosine law, where we've got two sides and the contained angle. Exactly, we would use the cosine law. So we need to find x. And just for the interest of time, I'm going to set it up, but I'll ask you to solve the problem. So we're starting with x here, so we know that the cosine law starts with x squared. And then we've got, I'm just going to go right to I didn't label any of the vertices of the triangle, which I probably should have. But I'm just going to substitute the values in. So we've got 150 squared plus 75 squared minus 2 times 150 times 75 times the cosine of 150 degrees. Okay, so that's all these pieces put together in the cosine law. So now just simplify it down and find the value of x, which is the distance from the gate where Fido enters to the tree where the cat runs up. Okay, so go ahead and finish that off for me, please. And then compare your answers with the answers of your colleagues.